Hello and welcome to this recorded e-learning on Xilinx Code Generator Utility. My name is Srikanth and I will be your instructor for this module. This module introduces the code generator and explains how you can integrate a core into your FPGA design. After completing this module, you will be able to describe the differences between a logic core and an alliance core solutions. Identify two benefits of using cores in your designs. Create customized cores by using the code generator software system GUI. Instantiate cores into your HDL design. And then run behavioral simulation on a design that contains cores. A core is a pre-optimized component that you can add to your design. Just like any other component you instantiate in your HDL. There is a wide range of cores that are provided through the Xilinx code generator. The simplest are provided for free and are made by Xilinx engineers. The components are the most frequently used and intended to help customers avoid reinventing the wheel. So they are sometimes the simplest to build but the hardest to code or optimize for in HDL. Xilinx logic core includes simple arithmetic functions such as adders, accumulators, and multipliers. There are also system-level building blocks such as filters, transforms, and memories, and specialized functions like bus interfaces, controllers, and microprocessors such as microplays. Most of the Xilinx logic cores can be customized by the designer for size, speed, or various options. There are also other more sophisticated cores called alliance cores that are made by the other Xilinx experts that are not Xilinx employees. The code generator also supports customers learning more about these components. Many of these cores have a charge, but that is because they are simply larger and more complex components that took them a lot longer to make. Using cores saves a lot of design time, whether that time would be spent writing HDL to serve the same purpose, or completing simulation, or even debugging. Using Xilinx cores assures that you get a pre-optimized component that is optimized to use the best device resources that assure the best performance and minimum device utilization. Cores have been built, tested, and simulated. Their guaranteed functionality helps assure optimum system performance, but this will depend on your design and whether the core would have been part of a timing critical path. But either way, the use of cores saves simulation and debugging time you would have to spend if you build the component yourself. Some cores contain mapping and placement information that enables the component to have predictability and optimum system performance. This is often the case when a core has a high performance timing requirement to meet a performance specification required by a design standard. The code generator includes a complete data sheet that describes the performance and device utilization when possible. Since not all cores require pre-placement, Xilinx still recommends that you use global and path-specific timing constraints to meet your timing objectives. So as I mentioned, logic cores are made by Xilinx employees and tend to be mainstream components that all of our customers can use. Alliance cores are also made by Xilinx experts, but they are called Alliance core partners. They are not employed by Xilinx. These components tend to be point solution cores that may only apply to a subset of Xilinx customers. However, these cores tend to be very sophisticated and will save you the most development time. To that end, they have a charge associated with them. Xilinx provides access to alliance cores as a service to our customers and business partners. We have a great deal of faith that these components will help you and that these vendors are reputable and provide good technical support to their components. Xilinx provides information about each core with the code generator's data sheet. We also provide you the ability to build the component simulate the core, and even download the core so you can determine if it is right for you. Logical solutions are typically customizable cores. They are fully tested, documented, and supported by Xilinx. Many of them are pre-placed for predictable timing. Many of them are unlicensed and provided for free with Xilinx software, but more complex logic core solutions are licensed. The logic core also supports the VHDL and Verilog flow to support several EDA tools. Alliance core solutions are point solution cores. They are typically not customizable, but there are some HDL versions which are customizable. They are sold and supported by Xilinx Alliance core solution partners. These partners can be contacted directly to provide the customized core you want. You can also get a free evaluation version of the module which is available in the list. But you will need to contact the IP center for licensing and ordering information. All these cores are optimized for Xilinx and some are pre-placed. The core is typically supplied as a EDIF netlist file. It also supports the VHDL and Verilog flow. This is a short list from a large library of optimized cores included with the code generator. As I mentioned, there are logic core solutions as well as Alliance core solutions. These logic core solutions are typically free and include functions like DSP, arithmetic, memories, and some hard IPs. Alliance core solutions are licensed IPs provided by Xilinx Alliance core partners who provide IPs like peripheral controllers, communication and networking IPs, videos and image processing IPs, and some standard bus interfaces like PCI, PCI Express core, etc. The code generator software is a utility that manages information about each available core, organizes core for easy browsing, and creates the actual files needed to integrate a core into your design. The code generator has a built-in datasheet for each supported core and describes the functionality and purpose of each customizable parameter. CodeGen is built to interface with many design entry tools, including schematic and HDL design flows. There is also a link provided to the Xilinx IP Center where you can always download the latest cores. This allows you to always use the best cores that target the newest FPGAs. The code generator is installed automatically with the ISA software. It is available as a standalone utility and is also integrated with the ISC Project Navigator. The latest version of PlanAhead, available in ISC 12.1, has the code generator software integrated and can be used to add codes to designs. To start the utility in the Project Navigator, use the command project new source. From here, you can select to add IP to your design, which is done using the code generator or architecture wizard. You then give your component a name and click next. The code generator will then open with a GUI that allows you to select the type of component you wish to make. From there, the GUI will provide a series of GUIs that allow you to customize the component's parameters and features. Please note that in the slide notes we have provided a little more detailed instruction to help you walk through this process. To start the utility in PlanAhead, click on Project Manager IP Catalog. This will open the IP Catalog window, and from here you can select to add IP to your design, which is done by using the code generator or architecture wizard. The code generator will then open with a GUI that allows you to select the type of component you wish to make. This screenshot shows you the first GUI of the block memory generator. After you have given CodeGen a component name, this GUI opens and allows you to see all the possible ports the component can have. Note that some of these ports are grayed out. If a user wanted to activate any of these unused ports, All you have to do is click on the customizable parameter buttons on the right that enables those features. So if some of the buttons are grayed out, don't panic. As you activate the features, the necessary ports will become available. You should also note that most of the GUIs have multiple pages of options. So after you have finished with these pages, look at the bottom and click the next button to go to the next page. If any of the options does not make much sense, review the datasheet to learn more about the component's supported features. You can check the version number at the top right of the GUI. Finally, after customizing the component, you will need to click on the Finish button. This will make the CodeGen create your instantiation templates and make a netlist for your core. On this slide, we are just showing you the datasheet for the block memory generator. The datasheet describes the features, parameter settings, functionality, and the pinout for the component. Note that pinout does not mean that there are implied pin assignments. This just describes the behavior of the ports associated with the component. Many of the codes provide performance expectations. However, the table does not always describe every device or supported speed grade. In case the core has a defined performance specification related to an industry standard timing specification, that information is provided in detail. But not all cores, especially not the block memory generator, have a performance requirement because it's just a block memory. Device utilization for various core configurations is also provided where possible. In this case, knowing the number of block RAMs used when a large memory is defined is helpful if you are trying to manage your block RAM usage. As I mentioned, the code generator supports schematic and HDL flows. Since most customers are using an HDL flow, we are going to focus on that flow. The .vho and .veo files are the HDL instantiation templates for VHDL and Verilog. They are provided by the code generator automatically, based on your design entry options you set with the ISE tools. Again, we will assume you have selected an HDL flow. The .vhd and .v files are the behavioral simulation wrapper files that you will require for testing your component with either ModelSim or Xilinx own iSim simulator. These files are also made automatically. CodeGen will produce an .xeo file, which is a component's options log used to create the core. This file is automatically associated with the ISE software and is frequently used to regenerate the core. Finally, the most important file made is the .ngc file. This is the core netlist that you will need to integrate the core into your design. It is the guts of your component, literally the heart and soul. Note that the code generator does not provide source HDL to designers. This flow protects our IP from corruption. One of the nice benefits of the tight integration of CodeGen with ISE software is that the language templates utility will automatically contain the necessary instantiation templates made for your component. To see the template, use the command edit language templates or click its icon on the horizontal toolbar from the ISE software. This will allow you to add the code to your design in XST or copy it to another synthesis tool for adding the core. After adding the code to your design, you probably want to perform a behavioral simulation to make sure it meets your needs. While this flow is also tightly integrated with the Xilinx iSim simulator, all the designers will have to run the cmpxlib.exe command to compile the behavioral simulation library. This is only required once and is usually done once when a designer installs a new version of the ISE software. You should also note that if later on you install a new version of the code generator to get access to your newly available code, this command will not have to be run again. All upgrades to CodeGen automatically install the new components compiled behavioral model for simulation. As I mentioned, the high endpoint solutions cores have a charge associated with them. The mainstream Xilinx cores do not. So first, If you have to pay for the core, you will want to run a behavioral simulation and make sure it meets your needs. If you have questions about Alliance cores, we provide vendor contact information on the IP center as well as in the datasheet. Give that vendor a call, ask all the questions you want, download the simulation model and test the core. If you decide you want it, call the vendor back, arrange payment and download the netlist and all the necessary files with that vendor's help. If the core is provided by Xilinx, give your hotline a call with any questions or concerns. Then all you need to do is instantiate the core into your design and copy the netlist into your project directory. Note that the ISC software will automatically use the wrapper files generated by CodeGen when the codes are being present in your design. Note if the ngc EDF file is not in the project directory, be sure to add the directory where the netlist stored to the core search directories properties of XST, or add to the ngc EDF file to your synthesis tools project directory. During the first stage of implementation, the Xilinx implementation tools will read in the ngc or EDF file that was created by the code generator software system. Again, if the core is not in the project directory, be sure to add the directory to the macro search path property of translate. If you are not sure what this is, go look for it in the command line user guide. Basically, it allows you to store your IP netlist in a separate directory outside of your project directory. As I mentioned earlier, you will have to compile the simulation library when you install updated ISC software. However, if all you do is upload some new cores, you won't have to compile the behavioral simulation libraries again. Please note, many VHDL simulators require low-level files to be analyzed before the file that references them. Remember to analyze the wrapper files for your codes before you analyze the file that references them. Also, if you are using a simulator that is not supported by compexlib.exe script, refer to the code generator guide and your simulator documentation for information on how to compile the Xilinx corelib library. In summary, a core is a ready-made and verified function that you can insert into your design. The Logico solution products are sold and supported by Xilinx. The Alliance Core solution products are sold and supported by Alliance Core solution partners. Using cores can save design time and provide increased performance. Cores can be used in schematic or HDL design flows. Well, there is lots of useful information about the code generator that can be found at the IP center. This can be reached from the ISC software by using the help command. The IP center will allow you to learn about new IP, update your code generator, find documentation about each core, and download Alliance Core IP for evaluation. If you would like to see what other courses we offer or what other free RELs are available, go to the Xilinx education link you see here. I would also like to mention again that there are other architecture modules available that discuss the basics of Xilinx newest devices. You may find this useful, especially if you want to learn more about differences between the available FPGAs. But whatever you do, please take a second and let us know what you thought of this REL. Just click on the icon on the next page and tell us what you think. My name is Srikanth. You have been listening to the Code Generator recorded e-learning module. Thanks for listening and thanks for your business.